What's going on, everyone? This is Devin from the Valve Amp Hobby Shop. So what you have going on here, what we have here is an attempt on my part to try to design a good turret board to handle all the components in the power supply, as well as all these various connections. And I can already tell you what you're going to see right here. We're not going to have a place to plug everything into, but we'll get to that towards the end of the video. So what I've done here in an attempt to try to wrap my head around this process is to go to more of a block style diagram. I've got some things color coded for ease of visualizing and that sort of thing. And pretty much all these components are going to be on any amp, right? Every amp is going to have a power transformer. It's a tube amp. Every amp's going to have a power switch, a standby switch, a pilot light, joule lamp. We're going to have to make connections to the preamp board for the those nodes, those voltage nodes. We're always going to be dealing with some kind of an output transformer and some kind of an output tube or output valve. So I've got all these connections numbered. I think I have like 15 in total that are in addition to the components such as your rectifier diodes, dropping resistors, cathode resistor and bypass cap, and the voltage divider for the heater circuit. All right, so let's one at a time. Connection number one. Do we have a place for the one of the two secondary wires for the power transformer? Looks like we have a winner right here. So obviously, we'll recheck that off. Number two can go right here. So we have that accounted for. What is connection number three? Okay, the standby switch. This would be from the rectifier to the standby switch. Looks like we have an option here. At this point, I would use the underside of the turret for that connection, right? I wouldn't make, just as an aside, I wouldn't connect any of these wires on the top of the board. I would come from underneath. Connection number four, here's our first little hiccup here. There's really no good place for the return wire from the standby switch back to the board. So number four is just kind of stubbornly not really accounted for. Connection number five, the center tap for the primary side of the output transformer. Once again, we really don't have a place for that. Luckily, for node number one, we actually do technically have a place for that right here, just before the first dropping resistor. I'm not going to use a choke in this design. So connection number 6 / node number 1, we have a place for that. Node number 2 or connection number 7, we have a place for that as well. Connection number 8, we could sort of kind of plug in number 8. I don't know if we really don't. No, there's number 8 right there. So we do have a place for number 8. Or no, or we. This is a maybe. I don't think we really have a place for number 8 because the filter node for there is right there, and so connection number 7 and 8 have to terminate basically at the same point. So we don't have a connection point for the screen of the output tube. So we're going to just assume this is going to be blank right here. I'm trying to figure this out more or less in real time with you guys. But so node number 3, connection number 9, we do have a place for that. Number 10 can go after that last dropping resistor, so we have a place for that. That leaves us in a little bit of a spot though, connecting to the preamp board on either one of those node connections, because again, I don't want to make a top loaded connection, and we've already sort of used up our connections there. So this spot right here, I guess, that really, in all reality, that could be used for that, which leaves us still with number 12, that we don't really have a way to get to the preamp board. So I did, in real time, I did figure out right in front of you guys that, yeah, technically we've got a connection to the board, because this point right here and this point right here, they're connected by a back jumper. So that did give us an extra spot for that. But again, connection number 12, we really don't have a place for that. So let's try to review real quick what we couldn't make a connection for. It looks like we don't really have a good place for connection number 4 or number 5. We also, number 8 was, I don't know about number 8. I do think we do have a spot for connection number 8. So again, what was that? 4, 5, and 12. So that's not too bad. So that's only 3 connections. By the way, there's a grand total of 15 connections here that are not part of the component board here. These are independent of that. So we got, what, 12 out of 15, so that's pretty good. So in the next diagram, we're going to go through here and resolve that. So what I did to fix 4 and 5, although these are numbered somewhat differently here, I added another turret row right here, a top one and a bottom one, and I jumpered from here to here and from here to here. So now we have a place for the return from the standby switch, which would go right here, and we now have a spot to bring our output transformer center tap into right here. So that's accounted for. We pretty much had all of our filter capacitor connection options here. We also had an option on the previous diagram for node number 3. We did not have a connection point for node number 4, or what we call connection 12. Again, the only thing I could really do is add yet another row of turrets here, 2 more, and so now we can jumper over from where we had our last filter supply capacitor. We'll jumper over to here, and now we can bring our preamp board, the last node number 4. Now that has a place to go. Now, as far as the cathode connection and our voltage divider for our power supply, our heater circuit, that's unchanged. So we had those things resolved before the fact. We had a connection to our cathode before, so we didn't do bad on this first attempt here, but it made it fairly easy to see as far as just what really didn't have a place to make a connection to. So I hope that sheds some light as to how you can start to triangulate and pinpoint connections that you just can't make. With this really, because what we're dealing with is more or less a high watt style turret board, in which all of your top loaded components will literally just be sitting side by side by side. There's some jumpering here with the rectifier. Again, there's some back jumpers, those kinds of things, but some of those I might do from the top side. Others maybe, maybe not. But for the most part, from what I understand about that kind of design, and some of the Voxes, the early 60s Vox amplifiers, even though they didn't use turrets, they used that terminal strip. It was kind of the same sort of philosophy as far as component placement and layout and that kind of thing. So that if I had to replace any of these components in the event of a failure, I'm not inadvertently impacting other components like the domino effect, unlike, a Fender or early Marshalls where you had, 2, 3, or, God forbid, maybe 4 things crammed into an eyelet or something like that. Harry Joyce and or Dave Reeves seemed to come up with a different system in the high watt amplifiers. And of course, Harry Joyce had his own line of amplifiers a little later. But again, I hope this helps. Those of you out there that might be considering designing something like this. And again, I kind of look at this as somewhat of a canon of design, in the sense that, as I've stated before, this is pretty much going to be the way it is to a greater or lesser extent, regardless of how much power, how much voltage the power transformer might have, irregardless of whether you're dealing with a push-pull or a single-ended output transformer. Most of these connections are just going to stubbornly have to be sorted out. So I hope you've enjoyed this. I always appreciate it whenever you stop by, and keep an eye out for the next one. Thanks.